Okay, so now we're covering the part of the test that's concerning the chain rule, the product rule, and the quotient rule. Okay. So the first question is the derivative with respect to x I'm writing kind of big, so I'll put this on 2 lines. Okay, so on this problem, we're going to have to do the product rule and a little bit of the chain rule. Well, it is the chain rule, but it's just spitting out that 3. Okay, so the derivative of sine is going to be now cosine of 3x, and now this is what I meant by the chain rule. We're going to have to spit out that 3. And this is still multiplied by x to the 7. Okay, so that's f prime g plus f. And then g prime is 7x to the 6th. F prime g plus f, and then g prime. Next problem is the derivative with respect to x. Ignore the little squiggly mark. That was a mistake. Okay, now the way I see this problem get done wrong a lot. So the derivative of secant is secant tangent. Okay, the way that most people get this problem wrong is they don't keep the x cubed inside of the secant and the tangent. It has to stay inside of both of them. So this is going to be secant of x cubed, tangent of x cubed, now multiplied by the derivative of x cubed, which is 3x squared. Okay. Now we're going to take the derivative with respect to x of the natural log Okay. Now, remember that the derivative of the natural log of x is just 1 over x. Okay? So what the natural log wants to do is it wants to, when you're taking its derivative, it forces that guy down to the bottom. So whatever you have on the interior of this, force it down to the bottom and then multiply by its derivative. Okay, so we force that guy down to the bottom, and now we're going to multiply by the derivative of the guy that we forced down to the bottom. So this first one is 5x to the 4th, and this one is 12x squared. Okay, that's our derivative. Okay, let's go ahead and go on to our second page, or third page. Okay, so this next problem is going to be a quotient rule. Okay. So we are going to try to take the derivative with respect to x of cosecant of x divided by e to the 3x. All right. Now remember, the quotient rule is f prime g minus fg prime, all of that divided by g squared. Okay? So, where f is on top and g is on bottom. So, f prime, the derivative of cosecant is negative cosecant cotangent. All right, f prime g, which is e to the 3x, minus f, and then g prime, the e to the 3x times 3, and then divided by e to the 3x squared. There we go. Okay, so we had equation number 1. Okay, this next one is just a power rule one, but it's kind of a mixture of fractions. So, say we want to take the derivative with respect to x of x. All right. Now, this first one, x to the 4 over 3. So it's to the 4 over 3, so we know it's going to spit out a 4 over 3, and it's going to drop it down by 1. So we would have 4 over 3, now x, to the 4 over 3 minus 1 is 4 over 3 minus 3 over 3, which would be 1 over 3. Okay. Now the next component, similarly to the previous problem, you can view this as a negative power. Okay? So if we're going to take the derivative of this guy, we need to recognize that that's really x to the negative 1/3 power. So it's going to spit out a negative 1 divided by 3. All right? Now we have to think about what the exponent is going to drop down to. So we're sitting at negative 1 over 3. So you think, all right, negative 1 over 3 minus 1. So negative 1 over 3 minus 3 over 3, well, that would be negative 4 over 3. Okay. Okay, this next guy is going to be another quotient rule. Right? So the derivative with respect to x of tangent of x divided by x to the 7th. Okay. So f prime g minus f g prime divided by g squared. So f prime, the derivative of tangent, is secant squared. So that's f prime, and then g is just f x to the 7th, minus f, and then g prime, 7x to the 6th. Okay, and I'm perfectly happy if y'all write it like this. Some people get the rules for exponents mixed up. I mean, if you wrote it as x to the 14, absolutely that's correct, but I have in the past seen people think that it's the other rule where you're supposed to add them, and we'll write x to the 9th, then I got to take off the point of that. Okay. So let's say, all right, our next one is the derivative with respect to x of cosine of x squared, now multiplied by the square root of x. I wrote that kind of in the middle of the page, but well. So the derivative of cosine is negative sine. All right, let's leave the x squared alone, and then we're going to have to multiply by the derivative of x squared, which is 2x. And then multiply, that's f prime g, so we have to leave the g on there, okay? Now, plus cosine of x squared. All right, now it's f prime g plus f, and now g prime. All right, so we're taking the derivative of the square root of x. This can be written in a couple of different ways. I'll do it in what might be the simplest way. Just 1/2 x to the negative 1/2. Or you can write this as 1 divided by 2 root x. And just throw that root onto the bottom of the problem. Okay. Okay. Now our next problem is a little bit of kind of a, there's an easy way to do it and there's a hard way to do it. Okay? So, the derivative with respect to x of tangent of x times cotangent of x. This is the same thing as writing the derivative with respect to x, not t, of tangent of x. Cotangent is really 1 divided by tangent. Okay? Okay. So on this problem, I would just look at it and say, that thing is 0. Okay? But if you want to do the product rule, it is going to come out to being 0. Okay? So, if we did this the other way, okay. All right, so for the tangent, all right, I got it. It ends up canceling out. There's probably some algebraic manipulation that's going to have to be incorporated into this. So if we had secant squared, that's going to be secant cubed with the cosine over sine. It's going to take some algebraic manipulation, but eventually it comes out to being 0. So you can do it either way. They're both correct.